Hi guys, my name is Peter C. Dogba Jr., your math tutor and an instructor of mathematics at the University of Liberia. In my today's video, I will be looking at differential equation and I'll actually be solving question number 2 under eliminating arbitrary constants to obtain the differential equation. So the question says x cubed equals 3x y squared plus a. So we told you in our previous video that whenever you have a kind of solution or a kind of functional relation and you want to convert that functional relation to the differential equation, thereby eliminating the arbitrary constants, what you need to identify has to do with the number of constants within this particular function. So we observe carefully and we know that we have a single constant. So we told you if you have one constant, you differentiate once. If you have two constants, you differentiate twice, and so forth. So the number of constants that you have within the problem determine the number of times that you have to differentiate. So for this, it's just easy. We differentiate once. So the derivative of x cubed is 3x squared equals. Now you have two functions here. You must apply the product rule. So we can hold 3. We just factor out 3. We hold x. We differentiate y. We have 2y. But since y is the name of the function, so we must attach y prime. Whenever you differentiate the function, you attach y prime. Plus, we hold y squared now and differentiate x. It gives us 1. Plus the derivative of a constant is just equal to 0. So now we have 3x squared equals, now we can multiply 3 times this expression is just 6x y prime, and then plus 3 times y squared is just 3y squared. So what we want to do, we want to write in a form wherein our y prime can probably be the subject, or they can all be on one side of the equation, whatever way you want to do it. So I can decide to say minus 6x, ascending this term across y prime, and then I send this term across as well, but this term is also here. You have plus 3x. Okay, so I read the y first, or whatever I want to do it. So I read the x first, 3x squared plus, so I'm sending this one across, 3y squared now equals to 0. So if I multiply the whole expression by -1, I'm just going to have all opposite signs. So it's positive 6x y prime plus, so this times this minus and this plus now goes to minus 3x squared, negative is positive, so it's 3y squared all equals to 0. So this could be one way of which you can express it. Another way could be by replacing this y prime by dy by dx minus 3x squared plus 3y squared equals to 0. So you can also write it in this form, or you can decide to multiply the entire expression by dx, so that you get rid of this dx from in the denominator. 6xy dy by dx minus 3x squared plus 3y squared equals to 0. So if I multiply the whole thing by dx, I'm just going to have 6xy dy. So this time this is minus 3x squared plus, so this is 3x squared dx, and then this is 3y squared dx again equals to 0. So since these two terms have dx, I can now say 6xy dy minus, I can factor out the x. So I can factor out the x like this, dx So what is left in this term? Now, if I'm also factoring out the negative, it means that this factor of negative must affect the both of them. So I will also decide to like factor out minus 3, right? So in here now will just be x squared. So negative times negative is positive, so it will be positive x squared. Then negative times this positive will give us negative y squared. So this could also be the differential equation. So either way, it can be expressed. It can be this. It can be this. It can be this. It can also be this. So if you have this differential equation now, we can be able to solve this differential equation, this first order differential equation, to arrive at this, our general solution. So that's how we eliminate arbitrary constant to arrive at the differential equation given the functional relation. So thanks ever so much for watching. See you in our next video.